फर्स्ट ऑफ ऑल अस्सलाम वालेकुम स्टूडेंट। आज हम लोग डिस्कस करेंगे जी वेक्टर के बारे में। वेक्टर एंड इक्विलिब्रियम, ये चैप्टर नंबर 2 है 11th क्लास फिजिक्स का। तो इसके बारे में आज हम लोग डिस्कस करेंगे। तो बिना टाइम ज़ाया किए हम अपना आज का लेक्चर शुरू करते हैं। इस वीडियो को आप लोगों ने लास्ट तक देखना है। इंशाल्लाह आप लोगों का कंसेप्ट क्लियर हो गए वेक्टर और इक्विलिब्रियम के बारे में जो है। तो ये एग्ज़ाम पॉइंट ऑफ व्यू के लिहाज से बहुत ज़्यादा इम्पोर्टेंट है फॉर लॉन्ग क्वेश्चंस एंड शॉर्ट क्वेश्चंस। वेरी वेरी इंपॉर्टेंट चैप्टर। तो आज हम लोग तो डिस्कस करेंगे जी वेक्टर्स एंड इक्विलिब्रियम। ये कुछ इसकी डायग्राम है जो आपको नज़र आ रही है। वेक्टर, सबसे पहले तो वेक्टर क्या होता है? सिंपल वेक्टर वो होता है जिसमें मैग्नीट्यूड के साथ साथ डायरेक्शन भी हो, उसे हम लोग क्या कहते हैं जी? वेक्टर। और स्केलर वो क्वांटिटी होती है जिसमें सिर्फ और सिर्फ मैग्नीट्यूड और डायरेक्शन ना हो। और इक्विलिब्रियम क्या होता है? सिंपल, जब कोई बॉडी रेस्ट की हालत में होती है या मूव करती हैं विद यूनिफॉर्म स्पीड के साथ, ठीक है ना, वेलोसिटी, तो उसमें वो होती है, वो भी हमारे पास इक्विलिब्रियम की हालत में होती हैं, ठीक है ना, कांस्टेंट इक्विलिब्रियम। अगर मोशन हो रही है कांस्टेंट है फिर भी इक्विलिब्रियम। अगर वो रेस्ट की हालत में मोशन नहीं कर रही फिर भी इक्विलिब्रियम। तो वो डिफरेंट स्टेट्स आ जाती हैं इक्विलिब्रियम की, स्टेटिक एंड डायनामिक, ठीक है। तो आज हम लोग डिस्कस करेंगे। तो बिना टाइम ज़ाया किए हम अपने लेक्चर की तरफ आते हैं। वेक्टर्स एंड इक्विलिब्रियम।
Number 11th class physics, chapter 2, vectors and equilibrium, detailed explanation. Image introduction. Chapter 2 explains vectors and equilibrium, which are fundamental concepts in physics and engineering. Many physical quantities, such as force, velocity, and displacement, have both magnitude and direction, making vectors essential for solving real-world problems. 1. Scalars and vectors. Scalar quantity. A scalar has only magnitude, size, or amount, and no direction. Examples: mass equals 10 kilograms, time equals 5s, temperature 30 degrees Celsius, energy equals 200 J, speed equals 20 meters per second. Vector quantity. A vector has both magnitude and direction. Examples: force equals 50 n east, velocity equals 30 meters per second north, displacement is 15 meters south, acceleration equals 9.8 meters per second downward. Momentum, scalar, vector. Magnitude only, magnitude and direction added by ordinary arithmetic, added using vector methods. Example: distance. Example: displacement. Number 2, representation of a vector. A vector is represented by an arrow. Length of the arrow, magnitude, arrowhead, direction. For example, a force of 20 n east is drawn as a horizontal arrow pointing east. Number 3, types of vectors. Unit vector, magnitude equals 1, indicates direction only. Common symbols E and K equal vectors. Vectors with the same magnitude and direction. Negative vectors, same magnitude but opposite direction. Parallel vectors act along parallel lines in the same or opposite directions. 0, null vector. Magnitude is 0 and has no definite direction. 4. Vector addition. A. Head to tail method. Place the tail of the second vector at the head of the first. The resultant is drawn from the start of the first to the end of the second. B. Parallelogram method. Draw both vectors from the same point. Complete a parallelogram and the diagonal represents the resultant. Example: if A equals 5n east, B equals 3n east, resultant equals 8 east. If A equals 3n west, resultant equals 2n east. 5. Vector subtraction. Subtracting a vector means adding its negative. Example: A equals 8n east, A minus B, find it. A minus B equals 3n east. 6. Resolution of vectors. A vector can be split into horizontal and vertical components. For a vector v, making an angle theta. Examples of 10n at 30 degrees. Horizontal component 8.66 newtons. Vertical component equals 5 newtons. Resolution simplifies the analysis of forces and motion in 2 dimensions. Rectangular components using x-axis and y-axis. Horizontal component x direction, vertical component y direction. This method is useful when multiple forces act at different angles. 8. Dot scalar product. The dot product of two vectors is Properties. Result is a scalar, depends on the angle between vectors, used to calculate work done. If the angle is 0 degrees maximum positive value, 90 degrees 0, 180 degrees negative value. Num 9, cross vector product. The cross product is vec A times vec B equals eta. Properties. Result is a vector. Direction follows the right-hand rule, used in torque, magnetic force, and angular momentum calculations. Number 10. Equilibrium. A body is in equilibrium when it remains at rest, or it moves with constant velocity because the net force is 0. First condition of equilibrium, the vector sum of all forces must be 0. Second condition of equilibrium, the sum of all torques moments about any point must also be 0. 11. Types of equilibrium. Static equilibrium, object remains at rest. Example, a book lying on a table. Dynamic equilibrium, object moves with constant velocity. Example, a car traveling straight at constant speed. Number 12, free body diagram, FBD. A free body diagram shows all external forces acting on an object. Typical forces include weight, gravity, normal reaction, tension, friction, applied force. FBDs make solving equilibrium problems much easier. Number 13, practical applications, designing bridges and buildings, balancing cranes and lifting systems, aircraft and spacecraft navigation, robotics and mechanical engineering, sports analysis, throwing, jumping and projectile motion. Important exam MCQs. 1. A quantity having both magnitude and direction is called a vector. 2. SI unit of force Newton N. 3. A unit vector has magnitude 1. 4. The dot product gives a scalar quantity. 5. The cross product gives a vector quantity. 6. A body in equilibrium has 0 resultant force. 7. Horizontal vector component uses cosine. 8. 11th class physics, chapter 2, vectors and equilibrium, short questions with answers solved. Q1, what is a scalar quantity? Give 2 examples. Answer, a scalar quantity has magnitude only and no direction. It can be described by a numerical value and a unit. Examples, mass equals 5 kilograms, time equals 10n. Q2, what is a vector quantity? Give 2 examples. Answer, a vector quantity has both magnitude and direction. Examples, force equals 20 n east, velocity equals 15 meters per second north. Q3, what is a unit vector? A unit vector is a vector whose magnitude is equal to 1. It is used to indicate direction only. Example, Ki and Kk are unit vectors along the x, y, and z axes. Q4, what is the difference between distance and displacement? Answer, distance, displacement, scalar quantity, vector quantity, has only magnitude, has magnitude and direction. Always positive, can be positive, negative or 0, depends on path, depends only on initial and final positions. Q5, what is meant by vector addition? Answer, vector addition is the process of combining 2 or more vectors to obtain a single vector called the resultant vector. It can be performed using the head-to-tail method or the parallelogram method. Q6, what is the head-to-tail rule of vector addition? Answer, in the head-to-tail method, the tail of the second vector is placed at the head of the first vector. The resultant vector is drawn from the tail of the first vector to the head of the last vector. Q7, what is the parallelogram law of vector addition? Answer, according to the parallelogram law, if 2 vectors acting at a point are represented by the adjacent sides of a parallelogram, their resultant is represented by the diagonal passing through that point. Q8, what is the resolution of a vector? Answer, resolution of vector is the process of splitting a vector into its horizontal and vertical components. Q9, what is a zero null vector? Answer, a 0 vector has 0 magnitude and no definite direction. It is represented by 0. Q10, what is the dot product of 2 vectors? Answer, the dot product is the multiplication of 2 vectors that produces a scalar quantity. It is commonly used to calculate work done. What is the cross product of 2 vectors? Answer, the cross product is the multiplication of 2 vectors that produces another vector. Its direction is determined by the right-hand rule. 12. Define equilibrium. Answer, a body is said to be in equilibrium when the resultant of all forces acting on it is 0, so it remains at rest or moves with constant velocity. Q13. State the first condition of equilibrium. Answer. The first condition of equilibrium states that the vector sum of all forces acting on a body must be zero. Q14. State the second condition of equilibrium. Answer. The second condition of equilibrium states that the sum of all clockwise and anti-clockwise torques acting on a body must be zero. Q15. What is static equilibrium? Answer. Static equilibrium is the state in which an object remains completely at rest because all forces and torques acting on it are balanced. Q16. What is dynamic equilibrium? Answer. Dynamic equilibrium is the state in which an object moves with constant velocity because the net force acting on it is zero. Q7. What is a free body diagram? FBD. Answer. A free body diagram is a simple sketch that shows all external forces acting on an object, such as weight, friction, tension, and normal force. Q18. Why are vectors important in physics? Answer. Vectors are important because many physical quantities, such as force, velocity, displacement, and acceleration, require both magnitude and direction for accurate analysis and calculations. Q19. Give two applications of vectors in daily life. Answer. 1. Navigation of airplanes and ships. 2. Calculation of forces in bridges and buildings. Q20. Why is equilibrium important in engineering? Answer. Equilibrium helps engineers design stable structures and machines by ensuring that the forces and torques acting on them are balanced, preventing collapse or unwanted motion.